Why? Hey, Will, don't hit me.
All right, there you go. You've got your shoe on tape. Okay.
Fine, Claire. Have it go.
Good job, Ryan.
All right. All right. There we go. So for the warm-up, traditional x squared minus 4, hush. So, moment about the y-axis. It makes sense that it's 0. Quiet please. Why does it make sense that our horizontal moment is 0? Because it's symmetric about the y-axis, right? Alright. So, our vertical moment, and by the way, you again do not have to do the whole integral by hand. I was just in a, hey, let's do it by hand kind of mood, right? Okay.
Never been in that mood.
So, anyway, so vertical moment, your moment about the x-axis, 1/2, add, subtract, -17-ish, right? All right. Mass is 32/3. That's just the area, right? Because it's area times density, but the density we're just using as 1. Yes, Troy.
Does it work if you do from 0 to 2 and you just multiply the 2 by 2? Oh, it's because of...
Yes, for this because of symmetry.
0
Yes.
minus. It's
All right.
0 minus. We didn't do 0 minus.
What's possible?
Yeah, you gotta do top minus bottom. Remember, this is below the x-axis. Yes, yes. All right, so, oh, yes, Joey.
Where would density, like, how would that vary? Like, it seems like if you had density for every single one, that would be...
All right, so for this class,
I got the wrong mass.
all of the problems that you will be given will be uniform density.
Okay.
So, yes, obviously there are flat solids where the density varies throughout the solid, and then the center of mass would be a lot more difficult to calculate, and I honestly couldn't tell you how to do it. However, for this class, all of the solids will be of uniform density, so you don't have to worry about it. Yes?
So if the answer is -8, I got both the, for the y coordinates, I got both the numbers needed to get that.
Yes.
But I didn't have either of them in fraction form, and I got 1.65625, whereas 8 bits is just 1.6. So with that.
Did you get this, did you put enough decimals out for this one? And you divided it by this with a bunch of 3s?
Yeah. Or it was 6.
6s, a bunch of 6s? And you didn't get that?
I got 1.65. Unless I did something, which is very possible.
Could you scroll up a teeny bit on that one?
Yes. Bye. 32/3.
Oh wait, I think I corrected for 0.
Yeah, we
That might be it. Okay, we got it.
Yeah, I was gonna say, I get -1.60000, so, yeah, you should to 3 decimals get that. Good, other questions? Okay, everyone okay?
No.
All right, all cell phones away, all laptops closed, all distractions gone. Okay. At the end of this lesson, you will be able to do 2 things. The first thing is calculate the centroid of a region, which you already know how to do, but we're going to do it once with a review problem and then once with a new type. And you're going to learn the theorem of Pappus today. Pappus. Or puppies. Yes.
Can I call him Papal?
No.
Okay, has no relation to the Pope at all. All right. Quiet, please. This whole screen is just reminding you, number 1, that when all you're finding is the center of mass, the density, as long as it's uniform, it's irrelevant. So you can ignore the density and just plug in a 1 for your row every single time. And then, of course, it's also teaching you that now you know the center of mass. It's one of those days. The center of mass is also called the centroid. So we talked just about centroids of triangles, but a centroid is just a name for the center of mass. So when we're talking about a region, if we talk about the centroid, we're really talking about the center of mass.
That's why I abbreviated it in all my homework.
Is it?
What?
You abbreviated centroid?
No.
Oh,
Center of mass.
oh, okay, alright,
Centroid is pretty short.
okay. Alright, so one more quick review problem before we move into some new stuff. So I want you to find the centroid of the region bounded by the graphs of y equals 4 minus x squared and y equals x plus 2.
So nice of you.
One last review problem.
I like when you tell us which is after that.
Just remember F is always the one on top.
Yeah, but,
I got a graph
but like
to
you,
make sure
you
which
gave
I
us a
know.
graph.
I did
So
give
we
you a graph.
can tell which is.
Yes.
You know, I don't know.
You got nothing.
That seems like a real problem. It's not super sharp, but it'll be in the
Yeah,
job.
like, I got it.
Okay, if you're gonna just sharpen yours then.
But that one doesn't shake. Keep
Oh my
breaking.
god, go sharpen it. Just go sharpen it.
Just keep breaking.
Go over there.
Do you want the fancy sharpener?
Is it
Yes.
electric?
No, but you still want the fancy sharpener,
I
trust me.
think I did the job. Maybe next
I
time.
think it's gonna be.
I'll be back.
Oh shoot.
You want the fancy sharpener?
Oh,
No, it's right with the fancy sharpener. I can bring it to you,
Oh my God.
right? Yes. Yeah. Now you have to figure out how to use it. That's part of the calculus of this class.
You know, hey.
I can confirm that I used exactly. Yes, I have come like halfway across
Yeah,
the
you have
school
to
just to
squeeze
use
them
that pencil
together.
sharpener before.
Yeah.
It's amazing and it always works.
Yeah, it's never broken a single one of my pencils.
Yeah, it's never screwed up any of my pencils. Like,
Like, I need one of those for my house. Like, actually.
that's a good point. Hey,
Raymond, do you know how to use it?
that's a complicated one.
Can I get?
Guys,
I had one just like it. It was here. You like pull it up. Wait, is it?
wow.
Your pencil is now through
Anyway.
Can someone
through
like?
its rite of passage.
I wanna look it up so I can get my.
So you can get your own? Alright. Everyone should be working.
Did you get an answer yet?
Yes, that we did.
Wow, you
Excellent.
must be so thrilled. I got that. I got the warm up right here, sir. Well, who's the one and on the warm up? Yeah, well, I beat you where it counts.
What's that supposed to be, Brian?
No, what's your GPA right now? What's your GPA?
Yeah.
On
And I was concerned.
3.96.
3.97.
You said you got 3.497. Dude. Yeah, how many A's? That means that I'm taking 9. So get right. Yeah, get right. GP's out window. Jump.
Brian, let's just see who gets a better job in the future.
I will. Wait, Will, what are you going into? Will, what are you doing? Oh, so you're gonna go into underwater.
Let's see who raises a family and is happy with
Alright,
this.
good.
I don't even want
Quiet,
kids.
quiet.
Honestly, he's probably gonna be arrested.
Okay.
Like,
I feel like Brian could be successful money-wise, but he's never going to be happy with his life.
I feel like he's gonna get arrested.
Like, I need him to
Dylan, you're neither gonna have money nor happiness.
Dylan, have you seen the show House? No? Not, okay.
That's the one to the doctor, right?
Yeah. Generally, he's just a really big, like, prick, but he's super smart, so everyone kind of accepts it. Brian's, like, almost at that level, but just not quite smart enough, so he's just gonna be a giant prick and get fired.
Will, you're not even in quiz. Go call. I could do better than 6, bro. Will, what place is It will.
No.
It's a sad day.
If you're not first, you're last. That's a lot.
Okay.
Open up for you.
Okay, quiet down. Hush. Now, remember, moment about the y-axis is just x, it's the integral of x times f minus g, right? X times f minus g. So your moment about the y-axis, x times f minus g, you should get negative 9/4. How is everyone good with that?
No.
That's the same as negative 2.25.
Yes.
And then yes. Good, all right.
It's like negative.
Oh, man.
Okay.
Oh,
Moment.
-1 to 2.
Stupid.
Yes, negative 2 to 1.
God.
Sorry.
Okay.
Well, this.
Oh, no.
That's because I rocked them too hard.
Tell you what,
Remind me to ask you about
Bureau of Criminal Apprehension for Minnesota. I'll tell you later. Okay. Alright. Moment of hush. Moment about the x-axis is f plus g, f minus g, all, times a half, right? So, I of course did it by hand, but you don't have to. The answer is 54/5 or 10.8. Everyone okay?
Yes.
Yeah.
Good. The mass is just the area, right? F minus g. So your mass is just 9/2, right, which is 4.5.
I knew that one.
Alright. And your center of mass, or centroid, is negative 1/2 12/5. Right? This is negative 0.5, and then this would be 2.4.
Yeah, but I converted it to the fraction for the end.
Good. Everyone comfortable with this? Okay, we're gonna move on to a new type.
Let's not.
You're gonna like this new type. It's actually very simple and it's kind of fun. So these are similar to, do you remember yesterday we did point masses in 2 dimensions? And all you do with the point masses in 2 dimensions is you take each x value times its mass, right? Plus this x value times its mass, plus this x value times its mass. You add them all together, divide by the sum of all the masses, and you get the x value of the centroid. So, same thing with y's. You take each y value times its mass, right, individually, add them all together, divide by the total mass, and you get the y value. This is the same thing. The only difference is it's just kind of a funky geometric shape. So what you do is you're going to split the shape into a bunch of individual rectangles or squares. So, and the first thing you want to do, your book it gives you these shapes with dimensions, and it says you need to lay them out on axes. So when I do that, I would just put them on the x and y axis, right, with the origin over in the lower left-hand corner. But, it's whatever you choose. But that's how I do it. Okay. Now, I split it into 2 rectangles and a square. You don't have to. You could split it into, a whole bunch of squares if you want to, right? Or you could do like rectangle, one big long rectangle and a rectangle up here, right? Or 2 rectangles and 2 squares. Oh my gosh, the possibilities. Okay, so anyway, however you choose to do it, here's what you're gonna do. Oh, wait, let me cover up the answer. I've got the answer showing. Okay, so here's what you're gonna do. Each of these has a center of mass. So the center of mass for a rectangle is the center of the rectangle. So I'm just going to give it to you for the first rectangle. It would be 1/2, 1 1/2. Halfway between the x's, halfway between the y's. Alright? So that would be the centroid for this rectangle. remember when we were talking mass for planar lamina, mass is density times area. If the density is uniform, is the density relevant for finding the centroid? No. So, for all the masses, we've just been using the area, right? So same thing goes here. So when we're going to do the x value of our center times the mass of its object, the mass, well, for mass, we're just going to use the area of the rectangle, right? So you do the x value times its area plus this x value times this area plus this x value times its area and divide by the total area, and you've just found the x value of the centroid. And then you're going to do the same for the y's. Yes, Dylan?
So, if it was to be like different densities, would you just do the exact same method just a third time with like the z?
I honestly don't know.
Okay.
Do you have to do that ever?
Probably
And I don't know if that's a z-axis problem, because the centroid, we're still talking, I mean, I see how you're saying center of mass, but you'd need functions.
But like, let's say like, like the first kind of rectangle there. that
Oh,
looks
has
like,
its own density,
Yeah.
and then his has a different density? I could see that,
Okay,
I could,
Quick question.
but I don't know, I've never done it.
alright.
Okay, so everyone, I want you guys to just try to see if you can walk through this problem without a whole lot of I gave you some instruction. Try and walk through it.
What even is the z-axis?
It's the third dimension.
Do we learn it in this class ever?
No.
I think you're doing calc 3 though.
Why?
Don't, you guys did z-axis in pre-cal, right?
No, I don't think so. We did it in geometry.
Wait, wasn't that the finance?
But that was more like how to graph it, which to be honest is pretty straightforward.
Didn't you guys do
You ace.
z-axis when you did vectors?
Yeah.
Yeah, three-dimensional, and you guys don't do matrices, but at least three-dimensional
Are you
vectors.
sure we did?
Okay. Yes,
So
sir.
you do x value times
The area of that rectangle.
area of that rectangle, and then
You do that for each of the figures.
Yeah.
Add them together, divide by the total. The center of mass, the x value of the center of mass.
and then you can do that to y, and then that.
This seems so tedious.
But then, you already know the center of mass of the. Oh, so you want to find the center of mass of the. Okay.
Wait, so you divide all the
Each x value times the area of its shape. Right? Add all those together, divide by the total.
And each x value would be the x value for the.
Graphing with the z-axis, like, if that's like, if we're looking at this.
Z-axis would be coming out of
It would be going through, okay. I couldn't remember like that.
Divided by the total area.
Well, when we draw x, y, z in 2 dimensions on paper,
Yeah.
traditionally, the x-axis is horizontal, the y-axis is diagonal this way, and the z-axis is horizontal.
Okay, so when you draw it.
But if the x and y are given like this, then the z would have to be perpendicular.
So it really, the z is kind of, the direction it's going is kind of arbitrary?
No, I mean, you have, those 3 axes have to be perpendicular.
Yeah. But I mean like, it could be going like, it could be this way, it could be that way.
Yeah, that's an interesting
But I would
thought.
tell you, traditionally, the z-axis, if we're drawing on paper 2 dimensions, the axis is going up.
So I could say that I am like standing within this room, like my head is at the point like 30,
Yeah,
like 20, 10,
sure.
5,
Yes,
6.
if we were to grid this in a whole big giant 3-dimensional coordinate
So
system.
this would be z.
Yes.
Okay.
If you wanted the x and y to be on the floor, then z.
But if you wanted x and z on the floor, then why would you going up?
That is correct.
This is weird, this right?
Well, it's just like
I
as
just
if
want
you
a
were.
standard like.
You want a standard like we have here.
Yeah.
Like an x, like a standard like we have x.
Because x is always this way and y is always this way. It doesn't have to be. X and y don't have to.
No, but
If
Dylan.
you lay it down, it's like that's what I'm saying. It's
Dylan.
X is always going to be the one like whenever you see a tradition.
Dylan, it is.
X and y, you're like.
Guys, quiet down, please. We actually had a question just now relevant to the problem. So,
No way. Well, you're lying.
It is standard. You're rotating
quiet down,
the
please.
whole axis.
This is being recorded.
Oh yeah.
So, okay, that's
Yeah, I
enough.
get that.
We're good.
Okay.
We're in 2 dimensions. So, here we go. For the
These little
center,
revolutions.
quiet. For the center of this middle rectangle, it is only 1.5 in from the edge of the rectangle, but we're talking about the x-coordinate based on the axes. So our x-coordinate would actually be 2.5. Does that make sense? It's in relation to the axes.
We have that.
Okay. Yes, Andrew?
Is it possible for the center of mass to be like not on the object?
Yes, absolutely. Guys, did you hear that question?
No.
Is it possible for the center of mass to not be on the object? Absolutely. Just think of a donut, right? Yeah.
Or I
So,
go like that.
That was
Yeah,
an
the
excellent
center-
way of describing that.
yeah, the center of mass does not have to be on the object.
You guys get,
Oh, I got it.
I'm glad I didn't say that anymore.
It was when I got arrested, and you know, they.
I think that was
I thought, oh, that's a great hug, and so I snuck it off a cop's desk. Yes. Yes. Yeah, that's just.
Archie got arrested.
No, it's.
Now you're screwed. That's why you got arrested.
Yeah.
I've been arrested.
Yep.
No, I've been taken into custody, but I've never been arrested.
Alright.
I just do the police part.
Okay, I need your attention, focus back here, please. So, whoops, I wrote rectangle. So, the center of the left rectangle is at 1/2, 3/2. The central rectangle, 5/2, 1/2, and then the square would be at the 0.51. So those are your centers for each individual shape. Okay, so for your x value, you do 1/2 times the area of the first rectangle, 5/2 area of the second rectangle, and then 5 times the area of the square. Divide it all by 10, and you get an x value of 29/10, or 2.9. For your y value, same thing. Each y value times its area, divided by the total area, and you get a y value of 1. So the centroid is actually at 29/10, 1, or 2.9, 1. So our center of mass for this region would actually be right around here, which kind of makes sense, right?
you put that thing on a seesaw.
Yes, yes, all right.
Well, wait,
Okay.
what if the middle, like, short but long bar is the seesaw?
Anyway, these problems will pop up again once in a while, and they'll be in your homework tonight, but that's all we're gonna do on it right now, because I think you guys can pick up on it okay. All right, so it's time to learn the theorem of Pappus.
Theory of paper?
Okay, so, I told a long story during first and third that almost didn't relate at all to this, just slightly. But I think I'll save it for off camera. So, anyway. It's really not that great of a story anyway.
All stories are great stories.
Alright, let's carry on.
The emoji, I like it.
You like the emoji? That's good. Okay, so as soon as I see Pappus, I'm like, oh, who the heck is Pappus, right? So I wanted to research Pappus so I could do a little screen biography on Pappus, right? Except when you pull up Pappus, not much is known about Pappus. Everything says not much is known about Pappus. So they don't even have a picture, right? So not even like a carving in stone or nothing, right? So, yes.
So, do you, and for your videos, what's like the farthest away for somebody like watching your videos? Like obviously people from Georgia and Minnesota, but like.
I just got an email last week from a teacher in Texas who has, hi, teacher in Texas, who's been using the videos. He's just started teaching Calc AB, and he's been using the videos and to help with planning. So, which is kind of fun. And he asked me for advice, and I'm sorry I haven't replied yet. I don't know what to tell you.
You gotta trust yourself.
Don't listen to Brian.
No, listen to me.
Gosh dang it, now I
Okay.
feel like we should be more polite.
No. He can
Okay.
get some education.
So anyway.
We all have to start dressing up and make it seem like we're all like
Okay.
This guy go on camera.
This price, like you should like put this on camera. Like what beauty. Like look how like
What the heck?
You gotta see it.
Why aren't we focusing?
Jared book clothes. It's like mispriced.
It's
Well, yeah, that's what I'm-
Do you want this on camera? It's actually a pretty good likeness.
You're doing it.
I take credit now.
Jared is so bad at math.
That was
Catherine
Mr.
Lee
Fogel is in our classroom.
from Bloomington, Minnesota.
Who is it?
Okay, there's my likeness right there for the camera. All right, good. All right.
In case they didn't know what
Okay.
it looked like from the
So let's talk about the theorem of Pappus. Quiet, please. Pappus, all I can tell you, he was Greek. He lived around 300 AD. He wrote a bunch of math texts, and most of them deal with geometry.
Oh, so it's
Okay.
Yay.
All right. Hand this back to Sorrow. All right. So here's what Pappus said, and you're gonna love this. And I thought third period reminded me of what I could have done with the next problem to be evil, and I wasn't evil. So you're getting the non-evil version. But I have a feeling, Mr. Thomas, sorry, but I have a feeling that Mr. Thomas is going to be evil to his students with the next problem. So I'll tell you how in just a moment. So here we go. Suppose R is any region in a plane, and L is a line in the same plane that does not intersect R. If little r is the distance between the centroid of R and the line, then the volume of the solid formed by revolving R about the line is given by 2 pi little r times the area of that region. Now, the area of the region, when you're doing these problems, to find little r, in order to find it, you have to first find the centroid, right? So you find the centroid. While you're finding the centroid, one of the steps is to find the area, right? Because that's your mass, is the area, because we don't multiply by density. So you found the area when you were finding the centroid. So you got the area, just integral top minus bottom, right? Then little r is the distance from the centroid to a line. All of the lines that you will be using will be horizontal or vertical. So those distances are really easy. They don't require distance formula. Literally, if this is the point 5, 6, and I say, hey, what's the distance to the x-axis? It would be 6, right? It's not like it's crazy hard. So your distance, your little r, once you have the centroid, little r is a piece of cake. So you just find, you do 2 pi little r area, multiply them together, done. No integral or anything. Okay? All right. So this is the theorem of Pappus. You have to know this. This is going to be in your homework, on a quiz, on a test, right? Okay. Now, the next problem. I want you to think back. When we did chapter 7 the first time and we were learning how to find volume, there was a problem that we made you do, and it was the volume of a shape called a torus. A torus is basically a donut, right?
Donut?
I don't know if you remember it or not, but finding the volume of a torus is not an easy task. It's kind of a cumbersome task, right?
Yeah.
We are going to find the volume. This is where I think Mr. Thomas is going to be evil, because I think he's going to make you do it the old way and then like see how fast it is to do it the new way, right? I'm just going to have to remember the old way, right? Okay, everyone remember it? All right, now, we're going to find the volume of the torus formed by revolving the circle with this equation about the y-axis. Now, think carefully. All you need is the centroid of a circle, right? The distance from the centroid to the y-axis and the area of the circle, right? Okay, so I want you to see if you can do this whole thing in under a minute, right?
That's so, you know I don't work long.
Okay, no time, no time limit.
Thank you.
Okay.
Yeah, she's gonna take the whole class.
Unit circle test.
But either way, no
Hard
matter.
time, stress you. Okay, I'll.
What am I trying to find? So just those things or
Jesus
that?
Christ, what is this?
We're trying to find the circle.
What is the centroid?
The vertex. It's obviously the outer shell.
Yup.
I like that.
How can, wait, Listen, how can it be the vertex though? It's not even touching the circle.
There is no vertex.
Why did I fall for that?
Witty banter. Oh, that's something. I didn't know that you could do that. Learn something new every day.
Whoa, you did it.
We got nothing.
I like that formula because it makes a lot of sense.
Yeah.
Like area.
It's, in a way, in my mind, it kind of relates to shell method a
Oh
little
yeah,
bit.
no, I was thinking it
It's
relates
similar.
to, well, it just relates to how integrals work, like for that, in general. I love the way this, like, whole class is set up where you do like the rectangles and then,
Yes.
because then integrals make way more sense, because you're like, oh, it's just like if you had like an infinite number of rectangles to
I have
put
the
in
TR1
like,
right here.
and it's the
Right.
same way, if you had an infinite number of those.
Can I fill this up?
Yes,
I'm
okay.
pretty sure this is like the TI3 4.
Alright, is everyone done?
Yeah.
Alright, let's see if you got it. What is the center of this circle? 2, 0. Would that be the same as the centroid? Yes, it would. Okay, what is the distance from that center to the y-axis? It's 2.
About 2.
About 2. Yes.
Give or take 0.
Alright, so
No,
now
give or
you've
take
got little r, right? What is the area of the circle? It's pi. So you, that was very anticlimactic. So, okay, so your volume of your torus is 2 times pi times 2 times pi, or 4 pi squared. Right? Isn't that cute? How lovely is that? Think about what that would have been with integrals, right? Okay, okay. So, that's the theorem of Pappus. Now, I need to warn you, the theorem of Pappus problems obviously are going to get a little bit more difficult. They're not going to be circles. They're going to be funky regions where you'll have to find the centroid, right? With the method you've been learning. So, you will, don't worry, I'm so glad you want to do one, and you will be doing some, but not at this moment. Okay, alright, so really quickly, we're just going to do a what have you learned, and then we have other things to talk about. So first, what is a centroid?
The center of stuff.
Center of mass.
Center of mass.
Can you find the centroid of a region?
Yes, actually, it depends.
On?
Can you apply the theorem of Pappus?
With circles.
Sometimes. Yeah.
Circles.
Circles.
Who was Pappus?
A Greek dude.
Some Greek dude.
Published a lot of mathematics.
Who was really shy because he has no picture.
Before or after the burning of the Library of Alexandria?
Alright.
Because